So we're going to look at a couple of examples, and I've sort of highlighted part of the question to show you key things that you should be looking for in these questions. So it says air is pumped into a spherical balloon. So we know the shape of this is going to be a sphere. And then we can start thinking about formulas for this in a second. So that its volume increases at 100 centimeters cubed per second. So the volume is this part here, the centimeters cubed, but you can see we've got the fraction here as well. So that tells you this is going to be dV by seconds is going to be time. So dV by dt equals 100. Now for sphere, we also know the formula for the volume of a sphere, and obviously volume is important for this question. So volume equals 4/3 pi r cubed. And notice that's not on the formula sheet, so that is one that you need to know. Oops. And that's what I just noted here as well. How fast is the radius of the balloon increasing when the diameter is 20? Well, it's a little sneaky to put this in here. As we're talking about the radius for this, to give this in terms of the diameter is not very nice. So the radius is 10 centimeters. How fast is the radius increasing? That suggests that there's something to do with time. So this is actually how quick is the radius increasing with respect to the time. So the question is, what is dr by dt? So that's what we've got to try and find. Now notice we have dv by dt, and we have an equation that has r in it, so we can probably use that to help us. So let's see what we've got here. If we use this as part of our related rates here, dv by dt, so this matches up perfectly now. I do have a dt on the bottom here. This doesn't include dv, so actually I need to get rid of the dv, but actually what I need is, I do need a dr on the top. So if I was to do dv by dt times dr by dv, it looks like the dv's cancel, and that leaves me with that. So how do I find dr by dv? Well, I could rearrange this equation for r and then differentiate, or I can do like I did last time in the warm-up. I can differentiate this, dv by dr, bring the 3 to the front and multiply, and then decrease the power by 1. And the connection between dv by dr and dr by dv is just the reciprocal. So actually dr by dv would be 1 over 4 pi r squared. And I think at this stage I can go ahead and reveal everything. So here's the related rate that I'm going to use. We've got our formulas here. When we plug these in, and also we can substitute in numbers now as well. So the radius we found out was 10. And then when we simplify all this, 100 divided by 100 is going to cancel. And so we get 1 over 4 pi, and then units as well for this question. The radius is centimeters, and time is measured in seconds. So let's finish that question off with an appropriate unit. Oil spill. Suppose an oil spill from a ruptured tanker and spreads in a circular pattern. So we know we're looking at circles here. If the radius of the spill increases at a constant rate of what? Also look for rates. That's another suggestion this is going to be a differential equation. How fast is the area of the spill increasing? So that's another rate question. When the radius is 30 meters. So how fast is the area increasing? So that's going to be dA by dt. We have a rate of 1 meter per second here. So meters is going to be to do with our radius. Seconds is to do with time. So this is dr by dt. Circle, as we're talking about area, we should be able to write a formula for the area of a circle as well, and then we could differentiate that to help us. So let's reveal all this stuff. So we know dr by dt is 1. How fast is the area of the spill increasing? That's dA by dt, and it tells us when the radius is 30 meters, so we got that part as well. We're trying to find dA by dt. Use dr by dt to help you, and then look what's missing. So we also need to use dA by dr. So when we cancel this out, we do end up with dA by dt. So to find dA by dr, we need an equation that says A equals, and then something in terms of r. So that should be our equation of a circle. Area is pi r squared. Differentiate it to get 2r. And then we can substitute into this formula then. So dr by dt, we were told was 1. dA by dr is 2 pi r. And then substitute in a radius of 30, so we get 60 pi. Units for this? Area is measured in meters squared, time is measured in seconds, therefore our answer is 60 pi meters squared per second. So you've got to do a little bit of work with these questions. Try and find out the key things that are being talked about here. Write down the key formulas out. Find out what your related rate is, and then substitute in to find your answer.